going to do just a couple more examples here of how to use the calculator and how to pick the numbers out of the problem, and also reintroduce XORT. Are we talking about a z-test or a t-test? So I'm going to read these instead of writing them down, and we can pull the numbers out of them, and if you need to, you can rewind and copy the numbers down yourself if you can't get them fast enough. So a program at Jefferson College claims the average income of its graduates is $45,000. I think that's high, so I survey 20 graduates and find the average of my sample is 38,000 with a standard deviation of 5,000. Okay, so the program's claiming that the average income is 45K. So the number in question here, mu naught, is 45. I think that that's high. So I think that the actual average is lower than 45. Okay, that's my alternate hypothesis. So I surveyed 20 graduates, so N is 20, and I found that the actual average of that sample, X bar, was 35. Is that what I said? I said 38. So 38K. And the standard deviation, which is S, because it's the standard deviation for the sample, not for the population, was 5,000. Okay, and hopefully you remember that distinction from before. Sigma is if you have the standard deviation of the population. If we don't have sigma, and we don't have at least 30 data points, we have to use t. And you don't have to worry about the difference between z and t mathematically. You just have to remember, if you don't know sigma and you have a small sample, less than 30, then you're going to go to z-test, or t-test, sorry, which is just one down from z-test. And the only difference, right, our mu naught is 45, that's the same. Our X bar is 38, that's the same. It's not the same number we used before, but it's the same information you're having to type in. Difference here is that SX is your standard deviation, so that would be 5 instead of sigma. You're still just typing the number in, it's just that the number you're typing it into is different. Our sample size is 20, and we believe that the actual average is less than mu naught, so we have to choose the less than option and calculate. And we get some pretty convincing evidence here. Our p is 2.59 times 10 to the negative 6th. So our p-value is going to be 0.0000006. So we would reject, right? This is how much doubt we have in our conclusion. We would reject the claim that the average is 45 in favor of the alternate hypothesis that it is less than 45. Okay, and that's because we had a fairly small sample, but the standard deviation was also pretty small, and our result was pretty far away from the college's claim. So we're pretty certain that they're not quite right with those results. Right, let's look at one more. The college claims the average commute time is 25 minutes. I'm curious if that's true. I don't have any idea if it's too big or too small. I just want to check. So I survey 100 students and find the average for my sample is 30 with a standard deviation of 10. Okay, so the college's claim, mu naught, is equal to 25. That's what they're claiming. I am curious if they're right. I don't know which way, so I'm just going to say it's not equal to 25 and try to show that. So I survey 100 people. That's my N, that's how many people I survey. The average for my sample is 30. And the standard deviation for my sample is going to be 10. Totally made up numbers. Now, my sample's pretty big, so my evidence should be reasonably conclusive, but I'm not actually that far off from their claim. My results are not very different from their claim, and the standard deviation is relatively large compared to the numbers we're dealing with. So we go to stat, over to test. Is this going to be Z or T? Yes, that's right. It's going to be Z. Even though I don't know the standard deviation of the population, I do have enough people. My sample is greater than 30, so I can use Z-test here. And the number we're looking at is 25. The standard deviation is 10. The average of my sample is 30. The number in my sample is 100. And I am trying to show not equal. And again, I'm not trying to show that because I think they're wrong. I'm testing their claim. I'm actually trying to prove that they're right by trying to prove that they're wrong and sort of hoping that I fail. So it's not that I want them to be wrong. It's that I'm testing. It's kind of like, when they crash a car, they don't want to hurt anybody. They crash the car to show that somebody won't get hurt. And once again, we get a very, very small p-value. So I have 0.000005 for my p-value, which is way less than any level of allowable doubt. So at the 5% or even the 1% significance level, I would certainly reject the null hypothesis in favor of the alternate hypothesis. So unfortunately, I believe their claim about the commute time is incorrect. I'm sorry I haven't done an example yet where we fail to reject. Do that next time, hopefully.